In this video we're going to be looking at some examples of rationalising denominators. Here's our first example: rationalise the denominator of 7 over root 3. Well, rationalising the denominator just means removing square roots or surds from the denominator. For this first example we want to get rid of the root 3 in the denominator. So what we're going to do is we're going to multiply the numerator and denominator, the top and bottom of this, by root 3. So 7 over root 3 is the same as 7 times root 3 over root 3 times root 3. They're equivalent fractions. I've just multiplied the top and bottom by the same number, root 3. Now the top we just write as 7 root 3, and the bottom, root 3 times root 3, is just 3. And notice now we no longer have a square root in the denominator. We've rationalised the denominator, so that's the answer to this question. Let's look at a harder example then. Now we're going to rationalise the denominator of 3 over root 2 plus 5. Actually, we're just going to write that as 3 over 5 plus root 2. It's the same thing. 3 over 5 plus root 2. So now again we have a root in the denominator. Slightly more complicated though, because we can't just multiply by root 2, because then 5 times root 2 will still give a square root in the denominator. So in this example we've got 5 plus root 2 in the denominator. We're actually going to multiply the top and bottom by 5 minus root 2. So this becomes 3, 5 minus root 2 over 5 plus root 2, 5 minus root 2. And the reason why we do this is because if you know anything about difference of two squares, this denominator is now a difference of two squares. A plus b, a minus b, is equal to a squared minus b squared. And because of this pattern, our square root of 2 will be, like the b, will turn into b squared, and that will then disappear as a square root. So let's follow this through. So the top of this fraction, if we multiply the brackets, is just 15 minus 3 root 2, and the denominator we can just do multiplying out brackets FOIL, so we get 5 times 5 is 25, outside's 5 times root 2 is minus 5 root 2, inside's plus 5 root 2, and our last is minus root 2 times root 2. So we've got our numerator 15 minus 3 root 2. Now the denominator, we actually get some nice translation. Minus 5 root 2 plus 5 root 2, these cancel out. And so we get 25. Now root 2 times root 2 is just 2. So we get 25 minus 2. And this then simplifies to 15 minus 3 root 2 over 25 minus 2 is 23. And clearly we have now rationalised the denominator. And you see this difference of two squares thing with the 5 plus root 2, 5 minus root 2 simplifies quite a lot into 25 minus 2. That's 5 squared minus root 2 squared. And that's just the same as 23. Okay, great. Let's do one more example similar to this one, just so we can have another practice with the So now our example is rationalising the denominator of 5 plus root 7 over 3 minus root 7. So now to rationalise this, we're going to multiply top and bottom by 3 plus root 7. So the denominator, but with the minus changed to a plus. Okay, and we get 3 minus root 7, 3 plus root 7. Okay, now we're going to expand the brackets. The top becomes 3 times 5 is 15. We get plus 5 root 7 plus 3 root 7, and plus root 7 times root 7 is just plus 7. And the denominator 3 times 3 is 9, minus 3 times is plus 3 root 7, minus 3 root 7, and root 7 times root 7, sorry, minus root 7 times plus root 7 is minus 7. And as we expect, we'll get some cancellation in the denominator. And now we can simplify this. We get on top 15 plus 7 is 22, 5 root 7 plus 3 root 7 is plus 8 root 7, and now we just have 9 minus 7 on the bottom is just 2. Now notice that all of these numbers are divisible by 2, so we can simplify this. This is just 11 plus 4 root 7.